Okay, so let's move on to Q&A session. And I'm going to allow participants to unmute themselves. And let me see, looks like Wayne raised his hand first. So Wayne, go for it, sir.
Hey, that was awesome. Really appreciate that. Really appreciate that presentation, the way you broke it all down and made it quite understandable and tied together a lot of dots, connected a lot of dots that I have personally been considering myself for quite some time, and it's just great to hear you say it so succinctly and clearly, those things that I've suspected, and I'm sure others have as well, regarding the acceleration of charges and how those have produced seemingly, in different experiments, produced seemingly these forces and impulses, in particular the Podkleinoff, the high energy discharges that he worked with that produced that gravitational beam, allegedly. So yeah, I just uploaded a video about rotating permanent magnets, and I had it on a digital scale, and I was seeing some changes on the scale, and it's always hard to know whether it's, you know, just an artifact of the induction and the electronics or whatever, but there was some changes there. And also Mark was seeing some with that rotating disc he made. So that's really neat.
That's the experiment we got to keep doing. We got to increase the sensitivity and increase the magnetic field strength. That's going to lead to the breakthrough. I am absolutely positive of that. That's why I wanted to bring up that experiment and add one more, which is kind of an Indiana Jones kind of idea. But we've noticed, many people notice that UFOs have a hum a lot of the time. And I believe that's because they're, especially in spherical shaped ones, they're doing just what I described in that experiment. They're turning magnets on and off rapidly and at really super high intensities, many Teslas, I'm sure, of flux is coming out of these things. Now, what we need to do is get somebody near a UFO with a portable oscilloscope and a coil of wire that's hooked like they used in the old AM radios, coil of wire hooked to an operational amplifier, and that's will be wired to maximum sensitivity. What we want to do is read for the rate of the magnetic pulses, how fast they're doing them, so we can reverse engineer this thing and get a jump start. If anybody lives near some place where UFOs exist and show up on frequent occasions, take this system out there with this sensor that I'm describing and try to get underneath it or as close as you can. Even a few thousand feet might do the trick. We want to see what type of wave. I suspect it's going to be a sawtooth, and what the frequency is. This is going to give us a good idea of what we should be doing when we build the experiment. It would be helpful to have. It's not absolutely necessary. I mean, we can do the experiment without knowing this, but I would like the confirmation that very strong pulsing magnetic fields are being used when they hover. So go on with your question.
Yeah, so it sounds to me like we're going to be needing to be using superconducting coils to get the strong enough, you know, flux densities that might make a.
It would be helpful. It doesn't have to be, but it would be helpful. I mean, we could still make some pretty strong magnets without that, or, you know, it gets very expensive if you have to super cool the cable to get it down to superconductive level. I realize that, but, you know, apparently our friends in outer space there have accomplished this, and I suspect strongly that the United States has already achieved room temperature superconducting wire and immediately classified it as top secret. So getting a hold of that stuff, it's going to be difficult, if not impossible. but I would recommend people go out and search for patents for superconductivity. There may be something out there that somebody overlooked, but yeah, it would be helpful if we had a room temperature superconducting magnets, but we got to do with what we got. And, you know, the strongest magnets we can build, and we build a very sensitive measuring mechanism. We have to try to use objects that are not magnetically, you know, ferrous materials for the weight, obviously would be a bad idea. You got to use something that's non-ferrous. You gotta even put shields around it, because the anti-gravity field cannot be shielded, just like a gravitational field. So you can rip along underneath it with an immense magnetic field. And if you want to be sure that you're not influencing the weighted object above, shield that, because the magnetic field underneath is going to do the work of shielding the gravity coming from beneath. So what we want to look for is a drop in the weight of the device above this apparatus.
Awesome.
Sorry, just one more comment, if that's okay. What you said about the constant current, you know, flowing in a wire, making a magnetic field. If you're familiar with the work of William Hooper, in his paper, actually in a patent of his, he made a coil with the wires going kind of back and forth, and he made a big bunch of it, a bunch of these windings, and so the magnetic fields would cancel out. But he talks about the V cross B field being something like an electric field that causes like a gravitational gradient due to the converging of the lines of flux. But he measured with an electroscope, he measured that slight potential that formed when these currents would flow in this coil, which is basically just copper wire, like a huge bunch of it, bundled together, kind of like a beer keg geometry, you know, like thousands of these turns. So all of this,
Right.
So he talked about
the
electron drift velocity, you know, like these electrons moving with a certain constant velocity, and that would, you know, be your B field, and then the velocity, so V cross B, would cause this type of electric field which would extend outward into space. So it's very interesting. It kind of relates a lot to what you were saying there.
That's the kind of the Byfield Brown technique. You can also create a propulsion using electrostatic fields alone, because they're twist to space. And if you can bunch them up, you can create a pressure, you know, and they use capacitors, I believe, and you can get a propulsion using, you can't really use it for an anti-gravity shield. It does provide propulsion and an anti-gravity effect because you create lift with it. But that's also something that can be done with an electrostatic field. But that method will never work for interstellar travel. The best speed you'll ever get is light speed with that. And it will be fatal trying to bring your ship up to that speed using that technique without a slipway bubble to be protected from the Lorentz transformation problems. That will occur as you accelerate toward the speed of light. You must be inside the slipway or you will perish.
Okay, well, so let me move along then, because we have several hands raised. But Wayne, thank you very much, sir. And let me go to Michael Boyd next. Sir, go for it.
Hey, Mark.
Hey, Michael.
I got a question about super relativity theory. How would the theory explain things like black holes and black hole jets or neutron stars, you know, basically where you have, basically my understanding of black holes is they're protons, and then neutron stars are a little different, but how would the super relativity explain those kind of star phenomena?
Before I answer, I'm going to ask you quick, did you read the 3 chapters on cosmology in my book yet, or you didn't get the book yet, right? Okay, so you really want to know how that works in super relativity.
Right.
I explain that in great detail in super relativity. Neutron stars are like the foundation of the universe. The neutron itself is such a great example of intelligent design. It behaves, as you know, it behaves differently under this different circumstances. What's really handy for neutrons is their neutral charge. That means you can really pack them together very densely, and the stronger you pack them, the stronger the gravitational field is. So what is a black hole? It's a neutron star. It's a very dense, very large neutron star. And so as this neutron stars get to be a certain size, it gets denser and denser, bigger and bigger, and then it overcomes the ability, the event horizon comes into play, and light can no longer be reflected from it. So black holes, according to the theory of super relativity, are caused by neutron stars.
So are you saying then that there's electrons in a black hole?
No, just neutrons. It's neutronium.
But
All you got, you see what you got. You remember where I showed you?
I'm a little confused because, as you're aware, there are no free neutrons. They decay into a proton, an electron, and some neutrinos. So they're not stable by themselves.
They're not free.
But
They're
a
not.
proton can be, you can have a free proton.
They're not free inside of neutronium. They're very closely associated. And in that instance, and in that circumstance, they last as long as the universe. If you were to take a single neutron, like you say, I agree with you what you're saying there, and you throw it out on its own in deep space, within 15 minutes, it'll break down into a proton, an electron, and a couple of neutrinos. Isn't that kind of perfect? If you get hydrogen, and isn't that exactly what you need to build the universe? So odds are, what I'm saying is, in the beginning, the Big Bang, the cosmic egg was pure neutronium. And when it let go of not only a huge amount of neutron plasma, which, as you would say, in this particular state, it's isolated, all those neutrons within 15 minutes turns into hydrogen. That's perfect. That's just what we need to build a universe. And along with that comes multiple size neutronium spheres, the elements, the seeds necessary to begin the creation of the universe. Because as they come out, they pull the neutron plasma with them, which converts to hydrogen. And now you're building stars, because in my theory, the cosmology theory, star formation is caused by neutronium spheres rapidly spinning. They gather the hydrogen gas. They are the cause, the central cause of the formation of all stars. And if you look inside of the sun, as we have done in NASA with a particular experiment, which I always struggle to think of the name, but it's a graph that they're determining the spin rate of the gases around the sun. And at the exterior, it's slow, but it's revolving. And as you get closer and closer to the middle, the gases start to become one, as if it were a solid. And then when you get really penetrate deep, it's spinning faster than the outer atmosphere. And that thing, whatever it is rock solid. Tackle line measurements, look it up from NASA. The evidence is there. It just has not been properly interpreted. They refuse to accept that there needs to be a cause for gravitational attraction of the hydrogen atoms, the proton. Protons, we know for sure, have an electromagnetic repulsive force orders of magnitudes greater than the gravity they put out. There is no way hydrogen clouds on their own are going to condense. You have to have a gravitational source. This is common sense. This should have been figured out decades ago. And yet here we are still trying to figure out how stars are formed. That's the theory of super relativity.
Thank you for your answer. I have one final question, which is, Do you think our universe is an open universe that goes on forever, or do you think it's a closed universe? In other words, does it have an inner and outer event horizon, or is it just forever and ever? Thank you.
Good question. Very nice. You know, I've used techniques that physicists would never use to determine things like that. That's a very deep question. So I've used experiencers, near-death experiencers who have claimed to travel beyond. Once you have passed away, you have powers, unlimited powers. And one person in particular said he wanted to see outside of the universe. So he did, and in an instant, you can travel anywhere by the speed of thought. And then he was looking at our universe, just this beautiful glowing orb with all the stars in it. And then he looked around and he could see other ones in like a grid work, but they were immensely far apart. So space itself is infinite. And the universes are being created, according to near-death people. Multiple people have confirmed this. They're being created by God. And in cases, he has shown them doing it. It's unbelievable to try to comprehend this stuff, because now you've asked a question that's beyond science. You're going to the core of reality itself, of who made it and how it's made. And that is something that you're going to deal with infinity and eternal. And it's a deep subject. It's a philosophic subject.
Exactly.
Thank you.
Yeah.
Philosophy and physics mixed. Thank you again, too.
Well, Michael, thank you, sir. Thank you. Let me go to Harold next. Harold, go for it, sir.
Thank you for your presentation. That was excellent. My question is, it's a two-part question. I mean, granted that the Maxwell equation for the speed of light, basically one can derive that by reducing the permeability and the permittivity of a space, you can go faster than the speed of light. Now, my first question is, how does your super gravity theory, super relativity, addresses for the engineering principle to achieve a reduction of the permeability and permittivity of free space when there's so many particles like hydrogen and other particles in the space?
Well, setting aside the particles there, but you just want to bias the spatial field, the ether, this thing, which is a quasi-elastic solid. So what you want to do is cause that solid to expand using the magnetic field. And so when you do that, see, there's a metric that's happening here. You're affecting the metric of space, the actual distance of things. So under flat space, a Euclidean geometry flat space, it's at a specific number determined by permittivity and permeability. When you use the magnetic field to pull it apart, you're going to reduce those numbers because you're reducing the amount of space in a given area. If you took a meter stick out into outer space and held it there, and you hit it with this big magnetic field around it, the speed of light would actually go faster across that meter because of the magnetic field. And because of that thought, because of what you're asking, I went and searched for something. I went and searched for an experiment that they shoot a light beam across a magnetic field. And I found one. It's called birefringence experiment. Mm-hmm. And sure enough, over the past, I don't know, 60, 70 years, the quantum mechanics predicts that the birefringence means it splits into two. You know, it refracts. There's double refraction. Mm-hmm. And when it's expected that there will be a positive number for the birefringence measurement. And that's what quantum mechanics predicts, but super relativity predicts a negative number. The speed of light should increase. In other words, the ordinary wave, which is normally the fastest of the two, the extraordinary wave will be faster, even though it's got a longer distance to travel because it's in a magnetic field. And everywhere I looked, they keep trying this experiment and they cannot confirm quantum mechanics prediction. And that's all they will say. I even wrote them. I said, did you notice that there's going to be an increase And then they got very defensive and didn't want to talk much anymore. There was a group that got a negative number for the birefringence measurement, and they retracted their paper. They were afraid of what was going to happen to them by saying one of the pillars of relativity, the speed of light is constant, is not really constant. And they did not want to go there. People get fired for claiming that. Look at what happened at the neutrino, the faster than light neutrino debacle. And so that experiment continues not to be confirmed. They just keep tearing it down when they don't get the expected result and retry it again. Something's up there.
Oh, no, thank you for the explanation. And the other question is, slide 23, you recommend an experiment. I believe that should work because I have done similar experiment with my proportion system that I've been investigating using magnetic field. And I posted 3 videos in internet that show exam magnetic field producing a proportion force, including wave reduction. I interpret it as thrust being produced by the arrangement of 2 orthogonal magnetic field, a rotor, one magnetic field spinning, like in slide 23, the other one is stationary, and it will produce a reduction in force. That I have confirmed my own experiment, which I will be posting video very soon on that particular subject. But my question is, I've interpreted as a thrust being produced, and that's why it looks like it is losing weight. But you do the other part that says anti-gravity, there will be anti-gravity effect. So how can basically distinguish between the two on the anti-gravity according to your relativity theory?
You're talking gravity shielding.
Right.
It's the same. If you create a gravity shielding, you're in the process of using and making an anti-gravity field. What you're doing is reversing the density of the metric of space using the magnetic field. So you're pulling it apart. And so that field, which is a contraction field, a gradient field, can't, penetrate through the magnetic field that's pulling space apart. So you're doing, basically you're creating a gravity shield. So you'll notice the thing above you weighs less. What you guys all got to do is get together and combine your results and your experiments. Keep doing the good work that you've been doing. You're on the right path. And if we just can't count on the government, they're never going to admit to this. And like Potlikoff and Ling Ni and all these people, they're just going to write them off and say, they'll say they did the experiment and it didn't verify. It's this technology is top secret. It's the best, most important secret in the history of man. They want to keep it private. So we, the people, this show, what we're doing here is vitally important. And I commend everybody that put this together. I commend you all. Mark and Tim and Jeremiah and Jeremy, all you guys, you're doing the right thing and you're making history. Someday they're going to look back on this and say, these were the heroes, the ones that made the breakthrough, that proved it beyond a shadow of a doubt. And this world will be a better place for it. I'm talking a utopian dream. And I support this. I support this wholeheartedly, what we're doing here. And I've tried to do my part. But in the end, we all got to work together. I'm not a great experimentalist. I got, a little thing I've tried in my past, but I'm gonna, let you guys take it from here. You're on the right track. As long as you're using magnetism, you're going to make discoveries.
Well, thank you. You look like you're a great theoretician and keep on working. You're doing the right thing. Thank you for the encouragement.
Wonderful. Harold, thank you, sir. Okay, let me go to Thomas Anderson next. Sir, go for it.
There we go. Can you guys hear me?
Yeah, you're a little faint,
Right.
but I can hear you.
A little faint. Okay. Maybe I can help that a little bit. Just that help a little bit.
Yeah.
Okay. I just had a comment, actually more than a question, about like or a suggestion when he mentioned the difficulty of getting a hold of room temperature semiconductor technology because of it, being hidden and whatnot. Something I kind of thought of a while back. If you look at the chart of elements and their conductivity, the highest conductivity you can get in any element that's out there is silver, and it's actually a really super weak superconductor because it's like 7% over that 100%, unlike copper that's just barely missing the mark at like 99%. And somebody else had mentioned like a couple of years ago that they're expecting silver to go massively up in price because they're going to find some sort of use. And he's using bot scrapers and whatnot, looking at languages coming from all these websites, from government websites to Twitter to anywhere else. And his supposition that he was getting is that it has something to do with the fact that the silver has a lot of radioactive, or I should say isotope states that have very long stabilities, so it would make them useful, and that would end up basically driving like the the difficulty to get your hands on it due to this. If they start finding a really good use for it, because one of those isotopes, they found a use for it. And it dawned on me, I don't remember when, but I remember hearing somewhere that to increase the conductivity of something, just add something radioactive to it. When it's an unstable material that's been added to a normal conductive material, it raises the conductivity drastically. So maybe enriching some silver and seeing if we can find one of those isotopes that would give us the room temperature superconductivity, even if it's only 200 or 300%. I imagine it would still give us the ability to do the other thing I was thinking of doing, which is to run an extremely high frequency EM field on your superconductors in order to get rid of the Brownian motion that's going on in the material that's all stuck together, so that it's all oscillating at the same time. That way all the electrons can be moved across each other with next to no effort through the system.
I see your idea. The key here, you want to build a superconductor, you need to make ion channels inside of that device. That's the key, so that the electrons can move rapidly, smoothly through the device without any resistance. And the first person that figures that out, my idea was to basically try different chemicals and materials and let the device cool while under a strong magnetic field, so that it would cool and crystallize in such a manner.
Oh, that way when you heat it back up, you can continue using it.
Yeah, it would.
Kind of
Yes,
like
when
making
it
an electron.
dries, it says, "Hey, I consolidated under a magnetic field, and because of that, I built ion channels." That's an
Right.
idea that I think that they should try.
Yeah, I thought some time ago, like I've been experimenting with bismuth and iron and a couple other elements with bismuth, about like trying to use tinning of just one portion of the copper wire while you're going, when you build your coils and whatnot, that bismuth is layered in there all the same direction. That way you could basically maybe increase the ability to basically to transfer the energy, so you get closer to that 100% of transference of energy with less losses and whatnot. And I have made a just as an experiment to see if it would work, I used acid rosin flux like they use in normal soldering for electronics, to see if I could solder onto a piece of steel with the bismuth, and because it melts at such a low temperature, and it worked with no problem. I ended up with one of the shims that I did this testing on was a triangular piece, so I had a real slim triangular like sharp point on one end that I could hold down with my fingernail. And I found that when I approached the side with the bismuth facing up with a magnet, I could get 4 times closer to that thing before it deflected and started trying to stick to the attract to the magnet than I could when it was flipped over with the iron side facing. And my thought, because it was like 1,000th of an inch of bismuth on a 3,000th of an inch thick shim, is that maybe the bismuth, until you get close enough that the bismuth effect on the steel, in order to enhance the bismuth effect, because bismuth creates a mirror effect, whereas magnetically, whereas the iron mimics it. So it'd be like, looking at a mirror that you see the back of your head for iron. Whereas when you look at a normal mirror where you see your reflection, your face, your two faces are facing each other with the bismuth, if you could get that iron to mimic the bismuth, you now have a really strong magnetic repulsion that's repelling those magnetic fields from the magnet until it breaks through to overcome the bismuth effect on it that's directly bonded to the material. And that's the only reason I could think that you could get 4 times closer from the bismuth side when there's literally a thousandth of an inch. It's like 25 microns of bismuth interfering with that magnetic field on that side versus the other side. It's behind it. It's on the.
Are you a
opposite
material
side.
scientist?
It's a I guess you call there's a demand for that in what I'm working on, and I've been working on this since I was a kid. I've just had a lot more
You sound like an alchemist.
and advancement now than before, because of all the ability to obtain knowledge and whatnot, to build replicator level upgrades for 3D printing. Because once we have the replicator, whether it's just taking atoms and putting them together to get whatever it is you're trying to make, or you're using energy to matter conversion and whatnot, all of the other things that we've been talking about doing will be a snap, because you can assemble anything at home on a desktop. No one can stop you, and you become completely disconnected from the rest of the system. So there is no control mechanism where they can centrally lock you down. Kind of like right now, if they want to stop you from having money, everybody uses banks. So they can go to that central location where your money keeps flowing through and interfere with that in order to interfere with whatever it is that they're trying to, affect on your life by using money to do that. You have a replicator, all you need are raw materials. They can be gotten anywhere. You don't have to go out and buy like this machine or that machine where you have to go to a specific company that makes those to get it, where they can then interfere and get between you, kind of the way Apple does with chips to keep independent repairmen from repairing the Apple devices. If you can print those, Apple can't do anything. All you need is the information on what the thing is made, how it's made, and then you can mass produce them and even upgrade the design. Once you have that information, then you can look at it and say, well, okay, this is a little thin, so that's why it's cutting out whenever you barely hit like 5 milliamps at 5 volts. Let's make it a little thicker so it can handle that, or use a different material, can handle higher temperature, and cut out the corner cutting that was done for the part before. Same thing can be applied to everything else that we're trying to do. So
well, Thomas, let me, and I sincerely appreciate it.
I should say one more thing.
Okay.
The reason I went through all that is because he asked if I was a material scientist. It's required for me to do what I'm doing. So that was just the explanation of why I have this kind of I guess more in-depth information on some of these oddball things that seem all disconnected.
Oh, no. Well, yeah, no. And I appreciate your comment. And yeah, I mean, you've had you've revealed amazing stuff, and you and Jeremiah have talked for hours on it too. But, but let me go to Mark Sokol next. And again, Thomas, thank you, sir. Mark, go for it.
Oh, to answer Mark Fiorentino's question to Thomas, yes, he is a material scientist.
Oh, that makes
yes,
sense.
He's like the garage tinker material scientist of our group, and we planned on having him on APEC. We're actually in talks with Tim, having Thomas on. He's putting a presentation together, and he has a wealth of knowledge on all different topics. This guy's freaking brilliant. So my question was about your the experiment that you showed, which is actually something we were already thinking of. We already are purchasing parts for it. We got the coils. There's a different design of a linear function as well, meaning that the magnetic coils are one on top of another. They're like pancaked. So you could do it like in a linear fashion, and basically a linear motor. Question is if you thought of any driver system to spin it, and at what RPM are we going to be spinning or turning them on and off?
I was thinking that you could use those high-powered silicon control rectifiers. You're familiar with that is what I would use. They're a little noise sensitive, but you can handle that.
Would putting a little bit of iron in, making them into a solenoid, would that help, or would that decrease the effect?
Well, any kind of a solenoid, it's got a reliability problem, but they, you know, they have limits to the current they can handle, and that when you're clamping that thing down and that spark, and you're pushing big currents, right? As big as you can get, it's going to tend to burn those solenoids out rapidly. So I'm trying to think, you get the heavy grade military silicon controlled rectifiers and turn them babies on and off, and they can pump out some power.
And any specific RPM benchmark we should be looking for?
Well, that's why I proposed the other experiment. The one where somebody gets underneath or near a UFO with this sensing device and reads the frequency that they're using. See?
Oh, okay. So
I
that's
answered your question, you didn't even know.
oh,
But I would recommend starting at 100 hertz at least.
okay. Fair enough. Thank you very much.
According to the theory of super relativity, the faster you go, the more amplified the anti-gravity, because you're causing that space to move. It's an elastic kind of thing it's mechanical. This is all mechanical. So you're causing it to move faster, and that faster motion causes a greater expansion rate, and you get a an amplified anti-gravity or a shielding effect.
Right.
It's all about
Also-
motion and force and motion.
Right. Later on, I hope to be able to present this. I have a spinning disc version of that with 6 neodymium magnets on it. And we're going to be throwing in also a high voltage potential across 2 plates that see what kind of effects we can get. We had a couple problems when I was testing this in the lab the other night. So I brought it with me, and I'm currently working on a solder point that broke.
I love that you guys are doing this stuff. It's really critically important. Nothing happens unless you guys do this. I mean, we won't advance. We can't count on regular physicists. You know, they're stuck in the quantum paradigm, and we can't count on the government. It's up to humanity to do this on their own.
That's 100% right. I was at the conference earlier, and Mark Millis, who's gave his last presentation of his career, he's retiring right now, and the presentation was supposed to be about alternative propulsion concepts, and it turns out that it was all theoretical assumptions that were, and then he had assumptions based on assumptions that will lead to a theory, and he was compiling them all in a database, and then that database is inaccessible. So he made an inaccessible database about assumptions on assumptions on assumptions of how we can get. And then I put in a question on the Q&A: Has any hardware been developed? Short answer: no.
Well, and it's inaccessible for a reason. They don't want you to see how it's built on piles of.
I think another thing that they do is the tinfoil hat conspiracy joke that they push you off. Oh, he's just a tinfoil hat conspiracy nut. Where'd that come from? I think if you're on the right track, a tinfoil hat becomes your PPE, becomes your personal protective gear if you're on the right track for anti-gravity. So they didn't make fun of them.
When they use name calling, that proves they're threatened. Or
Yep.
they wouldn't do that.
Yep, when they use name calling, it means you're on the right track. So if you get name called, continue. If you don't get name called, then you should stop and reevaluate.
Yeah. That one I don't care about. You call me any name you want. Just try the experiment. Just try this. I'm just the information giver. You're the man of action. You are the guys of action that are eventually going to make
not just me. There's a lot of people in here.
Yes, yeah,
there's a lot of people in here that are
Jeremy, all of you.
Gamble.
Yeah, the other guy.
Ron Kita.
There's a bunch of you, and the more the better.
Yeah, I mean, I would be here. I would be stuck here all day if I had to mention every single person that's actually getting involved. But putting your pedal to the metal, actual experiments is where it's at. That's what's important. Well, and, we don't see enough of that.
Yeah, let me move along because I've got Will next, and Mark, thank you. I've got Will, and then and this hands up thing. Actually, we're doing that again. I believe it's Option Y on a Mac or Alt Y on PC. And that actually that gets the questions in order, which is really cool. It makes it easier to go through them. So we'll go for it, sir.
I actually have two questions. On slide 24, I wonder, is your steering coils, are they stationary or moving?
Stationary.
And then you mentioned that you're pulsing from the front to the back. Are those like on-off coils? Or, you know, they're pulsed on and off, or are they continuously pulsed at the same time?
You know, I think it could work either way, but I imagine since so many abductees claim they hear a hum, that's a sign they're turning them on and off. So I'm going to go with the on and off based on that evidence from so many people. They all can't be wrong. There's something going on. You get a hum because usually there's a high intensity magnetic field somewhere banging away and causing things to move, materials in the ship or whatever are being affected by that. So I'm going to say that's on and off. It's like a rowboat kind of going through.
And then you have the magnetic shielding coil on that. How is that rotating, stationary? Because you only have one coil.
I'm not sure which coil. Did you say magnetic shielding coil? No.
Yeah, you have the big oval coil.
No, yeah, there's a
yellow
shielding.
one?
I recommend two types, the reflective shielding and the ferrous type, where you concentrate the lines of magnetic flux, and the other one where you reflect them. You want to use every kind of shielding you can, because it's very unhealthy for people in the ship to be exposed to extreme magnetic field strengths.
Okay, so I guess my question is that the yellow one, does that rotate, or do you have many different yellow ones around the hull?
I'm not looking at the drawing anymore, but the coils, none of the coils are moving physically. No coils move anywhere. The shielding, the room temperature coils, they're all stationary. This is all done electronically. This is the beauty of the thing. Electronically, it's much faster, more reliable. You really don't want to use spinning discs because the rate of motion, that they're going to have to be thousands upon thousands of hertz to get the same effect. And you better have a very well balanced system if you're going to do that, because the rigidity factor is going to come into play and the balance factor is going to come into play, and you're going to have one wobbly flying apart spaceship. This is all electronic, no moving parts are needed. You turn coils on and off, you get the motion from moving the field back and forth. It's very efficient,
So then
much simpler to control.
my last question, I noticed you use the standard electron model. What role does Cooper pairs play in your model?
What, I'm sorry, I couldn't make out what you said.
Cooper pairs, what role does that play in your model? You mentioned that you wanted to have superconducting materials, which obviously use Cooper pairs in order to create superconductivity. So how does that, what role does the Cooper pairs play in your model, if any?
Well, I'm not a real expert on material science or Cooper pairs, but all I know is you need to make a very powerful ion channel in the superconductor so that the flow of current goes unimpeded. And if Cooper pairs helps that happen, great. If not, you know, I don't know. I'm not into the real deep material sciences kind of guys. I highly respect what they do. And I think when superconductivity gets discovered, it'll be a material scientist, no doubt, that discovers it. Whether they'll be allowed to announce it is another story.
Okay, sorry, I said that was last one, but I really do have one last one.
Okay.
The magnetic fields that you're proposing, how many Tesla? And if it's a large magnetic, if it's a very high Tesla, it also means that you're projecting your magnetic fields up to several kilometers from your ship. How do you keep the magnetic field more constrained so that you're not actually affecting everything around you?
Well, that's a good question. You know, I suspect it's going to be over 100 Teslas, maybe more.
Well, then you're looking at a field that can go out several miles.
Well, not with any great
Because we see that with
noticeability.
the NASA test rig, which they put out into the desert, that was somewhere around the 100 Tesla. And it was at least 3 to 5 miles around the perimeter of their test rig.
Well, we're going to have to see by experiment how much is needed. That's why we need to do these experiments. I'm just making a guess there. I don't have any mathematics to predict the anti-gravity effect. That's a whole torsion field theory. Once we establish magnetism is going to affect gravity and be used for gravity shielding, people are going to get on this question that you have. And because we want to know, we don't want to have to make it any larger. It may not be 100 Teslas. It may only be 1 Tesla. I'm just taking an educated guess. We need to do the experiments to determine that number and work with that number. That's why I also suggest you got to move this thing. You will need less Gauss or Tesla if you move the field rapidly. The faster you move it, the less magnetic force you're going to need. So that may be around your problem of worrying about extending it too far out. Maybe the deal is you really need to rotate these fields rapidly so that you can use less magnetic field strength.
So I guess in that sense, if we consider what you just said, then you could say that perhaps using the magnetic field in conjunction with the Earth's magnetic field may actually help the device.
From what I understand, all the planets, the Earth, everybody has very far extending magnetic fields. And according to abductees, again, they use these magnetic fields not so much for helping them fly or anything of that nature, for navigation. That's where those kinds of fields are going to come into play. They supposedly ride these interconnecting magnetic fields across space.
Well, let me jump in now, Will, and thank you, Will. Thank you for the question, sir. Let me jump in, and Lulu, let me ask you to go next. Welcome back, ma'am. Oh, there we go.
Hi, how's everyone?
Welcome back.
Hi, thank you. I have a few questions for Mr. Fiorentino.
That's good.
Yes. Earlier in what you were talking about, I kind of wrote notes. So, I wanted to go with, you said about particles, like we don't know which way they're going to go and why. And, you were describing when like particles are, we just don't know. But I believe like particles kind of want to fill their valence shells. So they get attracted to something that, can share that. So, we could have a possible reason if it's not just random, like there is a particular pattern of and then fusion and then bonds, where particles become much heavier. So there are different factors in that, like that's very kind of important to like understand how like when hydrogen, becomes to helium, and then, lithium, and so forth, the process. Well, that's gaining, atomic weight, mass, like it's growing. So different departicalization and then reconfiguration into the new particle. I mean, that's like, fusion. So that's one thing, and it's always attracted to the stability point. And that's where it becomes ejected, let's say from the sun, this is happening. And then, it gets ejected, as a combined particles. We'll never know what they are, but we just know they're really, really fast, and, it creates like the solar winds and, stuff like that. So, this is one thing. The second thing, you were talking about, let's go back to the spirituality part, where at the end you were discussing that. Humans naturally emit something called biophotons, and it has an energy level, that could override, our observable universe. And, we dictate our observable universe. If we, the good saying says, you smile to the world smiles back. Well, yeah, I mean, really, it works that way. So, we do have a power, and that energy goes through the electromagnetic field, and it cycles. So the universe, reconstructs it back to you, because quantum entanglement. So it's going to come back no matter what. Like you emitted it as a a complex biological being. It's quantumly entangled to you, because it's a natural emission from humans. So that also is one thing. And quantum mechanics, the spin, like when the particle starts breaking down into different the smaller parts until wherever, well, those will always forever be entangled. So the spins will always be in unison, because it's still part of one. So it's going to be very difficult to measure, because you have to track so many, but the principles are there. That's how the universe is works. So all right, now the pion. Nobody likes to talk about the pion. That's like and like the pion is the I searched it, and has a something called MVE +1. So its charge is a positive charge. It it's infinite. It could have tunneling capabilities. It could go from one pole to the other. It doesn't abide by nothing. So and that's something that has a continuous propulsion. If we're talking about anti-gravity, well, that could be a core thing that we could start this. And when you guys were talking about governments and how they hide stuff, really, yeah, they do. But if you understand systems, and you understand, let's say, even electricity is a current, alternating current, zeros and ones. If you know how to binary code, how to you can know what was transmitted, just reverse engineer it just from the electricity. You don't even have to have an actual wireless network or nothing. Just somebody that understands. I know a bit, but not like I read to understand where I've come up with this knowledge. DNA structures. Our nucleic acid is a something in their space, or our core is a hydrogen core. I mean, that's they only say DNA. It's actually DNA and RNA. It's they don't talk about the other side, but that bond, that's a gap space. So that's another one. Now you want to talk about why the governments don't want to adapt the all the new research and the findings and the results. Well, it has to do with the Planck's constant, and it has to do with financial terminals, because if you update the science of this, it ripple effects to like when you run like a card or in any form of transaction that has an equation, and it abides by the constant Planck of the different metrics and measurements, and how it gets broken down to they give it like now in cryptocurrency, they have figured out this way, so they're riding on that energy residual of transmission. So
I know a lot about cryptocurrency.
I would love to learn more because, I already like earned, went to $112 and I a zero from my pocket. I just learned about, whatever they're offering. And I took the lessons and I started just playing with it. $0 out of my pocket. And, and it just goes up and down. And I was able to convert one to like a US dollar one that's, and I included $1.09 for the tax, just so they don't tell me when I tell them I want that paper and I want that sequence, that code from the Treasury Department, where I want to see that, transaction from this port to this port. How did this happen? Like how did you come up with that?
I got a question for you.
Yes.
Who's the biggest counterfeiter in the world?
Us. I don't know.
United States government.
Us. Yes. I mean,
well, and that takes us off topic a little bit.
Yes.
Actually, there is a really good. You might have to Google it, but there is a really good series that I saw called The Crash Course. And I'll try and put the link in chat. It has like a tree, and it's like a 14-part series. It would take you an entire weekend to watch it. It came out after the 2008 crash, and so that's the one that I kind of recommend to people. He just kind of walks you through the entire money system, but some of the things that Mark is alluding to there. The Crash Course really goes through that, and it wasn't based on crypto so much as it was based on the 2008 crash and a lot of the games that kind of came to light after that happened. So, but yeah, I'll paste that in chat. But Lulu, I'm sorry for interrupting you. Did you have a question for Mark?
I mean, I wanted to tell him all the stuff to take into account. Like, this is how the system, like our system of way of life is structured. I mean, down to the last bit, so don't be surprised when, the brightest minds come up with and they're not accredited to this. It's because then they have to, appease all other governments, all financial institutions, and that's just too much work for them to update things. And so, we have, many discoveries and many new things that are not applied because, they don't want to do the work. They don't want to update all this. It costs a lot. When you already have your port set and your transmission lines and, your grandfathered economic system that's like it's been going on for eons. Yeah, that's like, and everybody is, born with with a golden spoon in their mouth. And I bet you none of you even know how to really fix it. And that's one of the lacks on it.
I'm not going to try to fix anything. I'm just going to get information out here, and I'm not going to worry about who gets credit or whatever.
No, I really believe we have, I don't know, 48, 50 people, average, in that range. If we truly do combine, for example, I have over 72,000 documents of scientific information that combines, archaeology and geology, symbolism, and it breaks. But I have to put it somewhere, and I keep, I have to put it somewhere and categorize it. There are systems that are like blank systems. Like, for example, there was a system called an SDK. Almost a war between 18 countries broke out because they only had 26 of them. That runs a whole continent, what I'm talking about. Like it runs all the satellite systems. It's like your mother of mother, gate.
Yeah.
I mean, I'm telling you, I know I've personally updated. I was going to do my own, play test, mining system. I upgraded the electricity and everything. The second I started inquiring information and this, my life collapsed. My, all of it. The banking system is fighting me. It's so I'm living off of the cash world, and I keep on pissing them off just because I go and I deposit 1 penny, and okay, and I'm tracking it. Now what?
Yeah.
And so forth. But I'm playing with the system just to prove that, hey, it needs an update. From a person that really wants us to evolve as a species. I listen to Isaac Arthur. And he talks about, the future human, and there's a Kardashev scale, and why can't we have it all? I mean, we're right there. I mean, we're about to be classified as, civilization type 1. Hooray, but greedy people and ignorance is holding everybody back, and that's the
Yeah.
sad part. So I think either let's fix it for the idiots or teach them how to do it. And, if we consider our group as, visionaries, then I believe that we should do that. I mean, why not? Like, why not?
We're trying to make anti-gravity. That's what this is all about.
Yeah.
This
Who
is what
wants
it's
to,
all-
Yeah.
dance with the
Well-
stars,
Well, Lulu, thank you, ma'am. Thank you. And so let me go to William Schramm, who's been patiently waiting, and I just need to jump to him fast because we're pushing up against the hour. So William, go ahead, sir.
Yeah, this will be brief. So I'm an engineer. So my question to Mark is really a question about what can we build? What experiment can we run? It looks like the device you propose is a caterpillar drive, a linear, like magnetohydrodynamic type drive. So I guess a two-part question. What's the first experiment to conduct? And then the second one would be, have you considered a need for buoyancy for this craft? If it's going to be somewhere floating around Earth, have you considered how this craft stays up in the air when it's not in locomotion?
The buoyancy is accomplished by the field itself. By using the rotational magnetic field in this case, assuming a spherical shaped craft, or we could use the cigar shaped one. It's kind of pulsing back and forth in that mode. You get the anti-gravity effect because you're biasing space. You're going to cancel out the contraction, the gradient field of gravity by countering it with an expanding field. So you get buoyancy from the fact that the gravitational field can no longer influence your spacecraft because you've expanded the space around, you bias space, spatial bias drive. You've changed the metric, you've caused it to expand, and now the gravitational pull will not affect it. So there's your buoyancy. The other problem is you now want to use that same system for propulsion. So now you have to use a gradient magnetic field, something that spans across the ship in a particular direction, so that you have a really strong, powerful magnetic field at the back of the ship and a less powerful one at the front. And then increase that incrementally to the back of the ship. That gives you a velocity, a motion in a direction, propulsion. So you have both things handled simultaneously by using the magnetic field. And when you want to move, you use a gradient magnetic field. When you want to hover, you balance it, just evenly, back and forth, or either way. Hey, look, you go to these sites, landing sites where spherical or saucer-shaped things landed. Look at the pattern that's in the grasses. They're laid down either clockwise or counterclockwise. You're getting a really strong magnetic field that's whipping across and beating down the grasses. There's evidence right there that's been kind of overlooked. So my suggestion is to do just what I just said. You got to use a magnetic field, gradient, field strength, intensity from one end to the other. And when you just want to hover, buoyancy, whatever, you just make it even across the bottom of the ship.
Okay. And so in the case of the cigar ship, is it horizontal in orientation, or would it be vertical in orientation in order to remain buoyant?
Well, the rings, you're just sweeping across from front to back, continuously.
Maybe the question is, does it matter its orientation?
You're getting just enough, it's not going to move because, you're in between. The magnetic field is keeping you afloat as long as you do it at a fast enough rate. You don't want to do it too slow, you'll fall like a rock, or it'll wobble, which would be very bad. So you got to do it rapidly enough. I mean, you'll know this, you'll learn this by experimentation when you first start building these things and you see, oh, wow, 20 hertz is way too slow. We got to do, 550 or 700 or whatever to get this thing to stabilize. It's the kind of engineering and physics that guys like you are going to be able to figure out and work out those details. Right now, we have to prove to the world that anti-gravity fields can exist, can be made. We're at that point. We're not at this point where we're figuring out how to balance this. We're not even close to that yet. So that's my answer to that one.
Okay, thank you.
I can't hear you, Tim.
Oh, sorry about that. We are almost at the top of the hour. We've got 2 minutes left. Sorry, I forgot to turn my mic off there. So let me do this. Let me put this on gallery view. And everyone, please give Mark Fiorentino an enormous hand.
Thank you.
Mark, thank you. That was a wonderful session. Thank you for doing the Q&A. That was absolutely amazing.